Welcome. Today we will learn about queue data structure, its implementation using linked list in C++. Before going forward to the implementation of queue using linked list in Dev C++, I have a demonstration of queue, how it works and which are the basic concepts that are required to implement the queue in C++. So let's consider the practical demonstration and animation being developed by the InstMS binary visuals. We can also get help about this detailed topic of queue and its operation by just going through the InstMS data structure and algorithms and concept is queue. So let's start. Inserting a new element in the queue is called enqueue. We can enqueue any valid value in the queue. Let's suppose this is the 4, or we can also enqueue random values. Here is the option available to enqueue random values in the queue. Before going to the demonstration, animation, explanation, I have to clear the concept. We can enqueue, we can dequeue, we can enqueue random. Here will be the total nodes. This is the node structure that will be developed by us in Dev C++. This is the node struct that is being constructed by us. Have two parts, data and next. This will the output of dequeue or removed element from the queue. Okay, let's start by inserting random element in the queue. We can see that each and every element, here we have 7, first element is 4, and the new element or enqueue process is done on the rear end or at the end of the queue. The basic concept behind the queue is that the insertion and removal from the queue data structure performed at different ends. It may be in the ends of linked list, or these ends may be specified in array. We can see here enqueue process means insertion of new values performed from the rear side of the queue. And when we will try to dequeue operation or removal of data items, it will be performed from the other end, that is called front. We can see here we have lost element or first element on the front is 88. When we perform dequeue operation, this will be removed to 27, 335, 338, 543, blah blah blah. This is called dequeue process. And I have already told you what we are going to implement. This is called node structure. Here it is written the node structure that will help us to create a linked list in the data structure or Dev C++ for the implementation of queue. So let's start creating a new project using Dev C++. As multiple times we have discussed, we have to select project, console application, C++ project. Here I am writing the type and the name of queue. Okay, click on OK. Save the project. This is already exist. We can say here queue test. Okay. Again save the file, C++ file. I am typing here or pasting here the name queue test. This is the default program lines that are already written in this Dev C++, each and every new program. Now we are going to construct a new structure or struct for the node that will be used for the insertion of new elements in the queue. Because this implementation is queue implementation using linked list. You can also check our linked list video lecture in our playlist of data structure for more detailed idea how linked list traversal, searching, deletion and other operation can be done using linked list. Int data and node. This will be the pointer to the next node or linked node in the queue data structure. That can be named as next or pointer or PTR, etc. For the implementation of queue, we have to create a head node, because in linked list video session you can learn about detail knowledge about linked list and implementation. we have to require a node that is called head node. We can also rename it any other name and assign it null, because whenever we are required to work with linked list, here is the single pointer that will track, that will hold the information for traversal of the complete linked list. So after creating the head node, we are writing here the method that is called Enqueue, and it will take a parameter that will called value or val or data, etc. Whenever we have to insert a new value or Enqueue value, it is already explained in the visual animation. The Enqueue process will be performed from the tail side, from the end of the node. What is the identification that we have reached to the end of the node for insertion of new element? We can see here each nth element will contain null in its next pointer. So let's start implementation. First of all, we will have to create a new node that will be the part of queue after insertion process will be complete. We can create it using new operator and node. We can also use memory allocation method that will require std standard library lib to include in the project, or we can simply use new operator to create or allocate memory to the node pointer. And next process, we have required to put the data in the data portion of the newly created node that is called temp, and we have to place null in the next pointer of the newly created node temp. This process is much more simpler. This is much more simple. Create a new node, place the data value that is received as a parameter in the node enqueue operation, and place null. Why we are placing null? Because we are inserting element or new node at the end of the queue from the rear side. Here now we will require to go around the nth element of the queue so we can incorporate or part of temp node to the already existed queue. So that we say that if head is equal to null, it means there is no node or list or queue is empty. We will say that head is equal to temp. This process will assign the address of the temp newly created node to the head. Whenever we will traverse the queue, the head indicate the one and only one inserted element, single inserted element in the queue is temp. Because we have already checked head is equal to null. Else what will happen if this is the not first element that is going to insert in the queue? Then we will have to traverse the linked list. Why we are going to traverse the linked list? We have to reach to the nth element or the node that contains null in its pointer. For this purpose, we are going to create another pointer node that is equal to head. We have to start traversal from the head, so that we are assigning it head address, and we say that while ptr pointer next is not equal to null. This line I have already multiple times explained. Where the last node is indicated, it will identify it as the last node because its next pointer will contain null, so that we traverse the entire queue using our linked list using this while condition. What will happen in the while condition? We say that pointer or pointer temporary node is equal to its next. We will traverse one after another in the queue or linked list, such as climbing on the stairs. After that, the loop will be terminated when it reaches to the nth node of the linked list or queue. We will say that ptr next means the last node is retrieved and its next will contain the address of the newly created node is equal to temp. Okay, this is the insertion process. This is the complete Enqueue process. I am zooming out the code so the line of code are combined and accumulatively understandable. So now I am going to display a message after this complete else process or if process. We will say that cout well, that is the value, is inserted in queue successfully. Okay, after this I am going to use handle manipulator. Now we are going to write down the method that is called Dequeue. In Dequeue method we are not required to take any parameter because we are removing an item from the already created queue. First of all, we have to check either this queue contains any value or this queue is empty. We say that if head is equal to null, then just print the empty message cout queue is empty and just say blah blah blah, and we are going to handle. Okay, if queue contains elements, then we will have to say that cout head data, and we have to display the message removed. We have to place some spaces from the queue. Okay, we can have blah 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 handle manipulator. Why we remove the head data from the queue? Because each and every time whenever we perform dequeue operation, the value from the head will be removed. The value or node that points the head, it is the also point called front or front of the queue from where we want to remove the value. So that first of all we have to display the message is removed from the queue. After this we have to move head to the next node. For this purpose we can use head is equal to head dot next, and we can say here return 0 or return etc. This is the complete method for Enqueue and Dequeue. You can see that here is the simple method that can be implemented with just within a 1 minute of Dequeue process. Just remove the data containing the head node and move head to the next node. Now I am going to perform some operations in the main method so that the Enqueue and Dequeue process can be completely recognized or understandable. Before going to the main method, I will like to implement another method that is called display, so that we can monitor the position of the queue, how nodes it contains, because the linked list will not appear, not display all nodes if we don't write any kind of display method. For this purpose we have to quickly implement this method. If we say that if head is equal to null, what will going on if head is equal to null, just cout queue is empty and blah 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 and will manipulate. If it is this condition is not true, we have to traverse the entire queue. I am just copying this code that I have already written down for the sake of time saving. Just paste it what is going on, we are creating a temp node or head pointer node that is assigned by the head, and we say that while temp what next is, or we can say that temp is not equal to null, just move forward and print the data of the each and entire node. We have to write here cout temp data, and we can write here the vector, and we say here after while loop completion we have to show that the last node contains null. We just type here null and terminate the method. Okay, now it's time to check these all methods in the main method or main function. I'm first of all performing enqueue operation and providing value. Any random value can be provided. After this I will like to enqueue more values in the queue so the queue status can be viewed clearly. We say that 23 or we say that 56. After this we can display or dequeue the value from the queue. We say dequeue, and we then say display. We will have to see the status of the queue after these certain operation, what is going on. So let's execute the project. Here it says that cout cannot be used. I have already told in a video session that is the part of C++ fundamental program playlist. Here you can understand what is the main purpose of namespaces and how we can define user or standard namespace. This error is belong to the standard namespace. Okay, compile it again. Now we can see that 30 is inserted into the queue, 23 is inserted into queue, 56. What we were removal from the queue when we call, we do not told it queue to remove the 30. We just call 30 dequeue operation. Then it automatically dequeue 30 from the queue. Why? Because 30 is the first coming element or node in the queue. The first come first serve. The firstly inserted firstly will be removed. This is the queue methodology that is called FIFO, first in first out. After this display method we can also enqueue and other value that will part in last from the rear side of the queue. After this enqueue process I am again calling the display and dequeue method. So let's check it in execution what is going on. First of all we have inserted 30, that is inserted from the rear side. Then we insert 23, that is the part of the queue. After this we insert 56 sorry. Whenever we will try to enqueue the element from the queue, it first remove 30 from the queue because 30 is the first element that is inserted in the queue. After this we have printed the queue status. The queue status is that 23 and 56 is remaining 400. Sorry for that, I have not list handle after complete printing list of the queue. 400 is inserted in the queue successfully, and after 400 insertion we can see here the queue status is that 23, 56, 400. After this I have again remove or enqueue from the queue, that is 23 removed from the queue. Why 23? Because now head indicate that 23 because 30 is already removed or dequeued from the queue. These are the methods that are called it from the main function. I will try to explain the method that is called enqueue using linked list again. This is the method name that is called enqueue. We can also write down the method name as the insertion or insert. This is the parameter. For these three lines, I will say that this is the most important or most simple lines of the Enqueue process, complete Enqueue process using linked list. First of all, create the node, new node, insert value in the data part and insert null in the next part. Why we are inserting null in the next part? Because this will become the last node. We're just checking if head is equal to null, then this temp will be the null. And if this is not true, then we have to move to the end of the nth node in the linked list or queue to approach the null pointer. What it means that the last node will contain the null. After traversal and insertion, we will just display the message that queue, an element is inserted in the queue successfully. So nice, keep in touch and subscribe our channel. Next we will discuss binary search tree implementation, that is also linked to the queue and linked list understanding. For the better understanding of linked list, check our video session that is called linked list implementation in the data structures playlist. So nice, thank you.